You are welcome to Dynamic Educational Hub channel, your answer to the very question. This is a channel where you learn your physics, mathematics, and chemistry. If this is your first time of coming across my channel, kindly subscribe to my channel and click on the notification icon in order to get notified when I release a new video. This video is a continuation of what we have learned earlier on, which is continuation of cofactor matrix, and we are going to look at the inverse of 2 by 2 square matrix and also solve examples on inverse of 2 by 2 square matrix and also have an exercise. Without further delay, let's start the class. Inverse of square matrix. An inverse of matrix A simply means you raise the power by -1. So inverse of number or algebra is when you raise the power of that thing by -1, -1. So inverse of number simply means you raise the power by -1. So for square matrix A of order I by I, that square matrix, when you multiply it by its inverse, you are going to get a unit matrix of order I by I. So this is a formula to find the inverse of square matrix. So to find the inverse of square matrix, you use this formula, which is adjoint divided by the determinant of that matrix, and is 1 over determinant multiplied by adjoint of that matrix. To find determinant, you use this formula, which is adjoint divided by determinant, which is 1 over determinant multiplied by adjoint of matrix. A matrix can only have inverse if the matrix has a determinant that is not equals to 0. For a matrix to have inverse, when you compute the determinant and you get 0, it means that that matrix is not going to have an inverse. So since it is only square matrix that has a determinant, every other matrix has no inverse. So every order of matrix that is different from square matrix, any matrix that is not square matrix is not going to have inverse. It's very difficult for you to compute the inverse. So which means that the first condition for a matrix to have inverse is the determinant must not be equal to 0. As such, the matrix must be a square matrix. Let's look at an example. Find the inverse of matrix below. So if you have to find the inverse of this matrix, how do we go about it? The first thing is, remember your formula, which is adjoint divided by determinant, also 1 over determinant multiplied by adjoint. So if you are finding the inverse of this matrix, it means that you are going to have 1 over the determinant of this matrix multiplied by adjoint of that matrix as well. Now to solve it, the first thing you have to do is find the determinant. To find the determinant, don't forget, if you haven't watched my previous video on determinants, vector multiplication, scalar multiplication, addition, subtraction, properties of matrix, minor, and cofactor, kindly watch the video. Now to find the determinant of this, you multiply across the diagonal, you have -1 multiplied by 2. And don't forget, here you are going to have plus, here you are going to have minus, then minus 3 multiplied by 6. When you do that, -1 multiplied by 2, you get -2. 3 multiplied by 6, you get 18. And because of this minus, you have -2 minus 18. That gives you -20. That is the determinant. Now, the next thing is to compute the adjoint of this. To find the adjoint, I've given a short method, a short way of finding adjoint of 2 by 2 matrix within few seconds. So what is that short and very fast method of computing adjoint of 2 by 2 square matrix? The first thing is you will swap this diagonal. Swapping it, -1 come here, then 2 goes there. The other diagonal, you find the additive inverse. So they are plus before. When you find the additive inverse, they becomes minus. That is the adjoint within few seconds. Now plug in this into your formula. What are we going to have? Inverse of this is going to be 1 over minus 20, which happens to be our determinant, multiplied by this, which happens to be our adjoint. If you look at this very well, you are seeing a scalar multiplication. Multiply these together, 1 over minus 20 multiplied by 2, you are going to get 1 over minus 10 for this one. The next one, you have 1 over minus 20 multiplied by minus 30. This minus, we cancel this minus, you are going to have 30 over 20. Then for this guy, you have 2 in 20, you have 10. 2 in 6, you have 30. And this minus, we do with this minus. This minus divided by minus, you have plus. So that is why you have 30 over 10. Finally, you have 1 over minus 20 multiplied by minus 1. This minus, we deal with this minus. So you are left with 1 over 20. And this is the inverse of this matrix. Very simple. So that is what I've done. Let's see if the answer is actually correct. Don't forget, when you multiply a matrix by its inverse, you are going to get a unit matrix. So since we are dealing with 2 by 2, if you multiply that matrix by its inverse, you are going to get this unit matrix that is 2 by 2. So when we multiply these two guys together, we must get a unit matrix of order 2 by 2. If you haven't watched my video on vector multiplication, watch it. And that is what I've done here. I've multiplied this with this. So we are going to get this. So if we compute this value, what are we going to have? We are going to have 1 over 10 plus 9 over 10. This one becomes 9 over 10. This one becomes minus 3 over 20. And this one becomes 3 over 20. Then we have this as well. For the second row, we have this. Now, at the end of the day, when you complete this 1 over 10 plus 9 over 10, you have 1. Minus 3 over 20 plus 3 over 20, you have 0. Then minus 6 over 10 plus 6 over 10, you have 0. Finally, 9 over 10 plus 1 over 10, you have 1. And if you look at it very well, you see that we have a unit matrix of order 2 by 2. So which means that our inverse is correct. And let's have another example, which is this. Find the inverse of matrix below. So we want to find the inverse of this. To find the inverse, the first thing which you want to do is you find the determinant. So let's find the determinant of this. Finding the determinant, we multiply across the diagonal. 5 multiplied by 1 minus 2 multiplied by minus 3. Solving this, we are going to get 5 multiplied by 1, 5. 2 multiplied by minus 3. 2 multiplied by minus 3, you have minus 6. And because of this minus, it becomes plus 6. So 5 plus 6, that gives us 11. The next thing is to find the adjoint of this matrix. To find the adjoint, you swap this diagonal. So this one becomes 1 and this one becomes 5 when you swap them. The other diagonal, you find the additive inverse. Find the additive inverse, which means you give them negative, negative. Now doing that, we are going to, this one will become 3 plus 3 and this one will become minus 2. So this is the adjoint. And don't forget our formula. Inverse of matrix is 1 over determinant multiplied by adjoint. So let's plug in our value. Plugging in our value, we are going to have this 1 over determinant, that makes it 1 over 11. This is the adjoint that we've calculated here. Now multiply this scalar multiplication. 1 over 11 multiplied by 1, you have 1 over 11. 1 over 11 multiplied by minus 2, you have minus 2 over 11. 1 over 11 multiplied by 3, you have 3 over 11. Finally, 1 over 11 multiplied by 5, you have 5 over 11. This is the inverse of this matrix. Try to solve this question by yourself and comment if you actually get it in the comment section. Now before the end of this video, I would like to give you an exercise and find the inverse of the matrix above. So if you are to find the inverse of this matrix above, solve it, pick the correct answer and comment in the comment section. Let me see if you actually get this question. Try it, solve it, comment it in the comment section. If you have watched my video to this point, it shows that you actually love my video and you have been following me. If you haven't subscribed to my channel, kindly subscribe to my channel and click on the notification icon as shown. Like my video, share my video with students that you know is going to benefit from this video. My next video is going to be an interesting video, which is going to be proof of inverse of matrix formula. That formula, how do we arrive at it? So I'm going to prove it in the next video using algebra. How do we arrive at 1 over determinant multiplied by adjoint of matrix is going to give inverse of matrix. I'm going to show it in the next video. Like my video, share my video and comment. Thanks for watching. Stay blessed. See you in the next video. Bye for now.